Hello and welcome to my first ever YouTube video. So I'll give you the disclaimer first. I don't know anything about video making. So this is my first trial and yeah, so we'll discuss about something educational. So please bear with me so you can learn something. And yeah, first let us discuss about laptops. Current generation of laptops comes with inbuilt batteries. Yeah, even some gaming laptops are bulky because of that batteries, and even it doesn't give that much long range like that of old laptops because of its smaller size. But if I say, if we change that battery to something new or some different device, we can improve the battery life as well as its storing capacity, including its switching speed. It's like making your computer faster by changing one device. Obviously, I think you might have guessed what I'm talking about. It's supercapacitor. Actually, supercapacitor are not like directly used as batteries, but in modified forms, it can be used as batteries because of its very uh, desirable qualities. Okay, so let us begin the topic, which is the application of polymer in fabrication of supercapacitors. And in this video, we'll look about supercapacitors and polymers, conducting polymers, and also the types of capacitors. There are two types, like based on the mechanism of charging, and also types of capacitor based on polymer which they use as electrodes. And we'll discuss about polymers, that conducting polymers which are used in electrodes, some, and also we'll discuss about two particle polymers. Okay, so let us begin. You can myself Prakshat from RVCE Aerospace Department, and this is an assignment to our beloved chemistry sir, Vishnumurthy sir. And okay, let us start. What are supercapacitors? As the name itself suggests, there are two parts in the name, super and capacitor. Capacitors are the same thing which we have learned in 10th standard or 9th. What are supercapacitors? What are capacitors? Capacitors are basically an electronic device which stores charges that are energy. So it stores charges, or you can say it stores energy. What are supercapacitors? These are the capacitors which has the ability to store higher energy. So it has supercapacitance, high capacitance, and also high energy density. So why are these are more like, why we desire more about supercapacitor? This is because of its high switching speeds, that is high charging and discharging speeds, and it has very high cycle, like charging and discharging cycle. If you compare the regular capacitors, it has 10 to the power 3 cycles, whereas it is not less. But compared to supercapacitors have 10 to the power 6 cycles, which is obviously very high. And yeah, where are these supercapacitors used? This is the definition of supercapacitors, you can see here. And these supercapacitors are used in automobiles for regenerative brakings, that is to brake very quickly and efficiently, like super fast braking, and short term energy storage, and also in burst mode power supply. That means power supply is very dynamic and very fast. So okay, so polymers, as I mentioned, polymers in the application of supercapacitors. So why polymers? First of all, what are polymers? Polymers are long chained molecules consisting of repeating monomer units. I'll give an example for this, very simple. Consider bicycle chain. You can see it's a long chain made up of small chain links. Similarly, polymers are the long chain made up of small monomer units. And there are many types of polymers. Uh, Conduction polymers or conducting polymers are one of the major and leading technologies today. And what are these polymers? These are the polymers which can conduct electricity. Basically, conduction or conducting polymers are made up of conjugated structure. Conjugation means alternate double bonds. And you can see, for example, we have polypyrrole, polyaniline, etc. And why we should consider this conducting polymers? Why can't we use traditional metal electrodes? Because of the properties of these conducting polymers, which increases the capacitance, and also it increases the energy density. Basically, it improves the capacitor to supercapacitor. Hence, we are using conduction polymers. Okay, so now we look at these categories of supercapacitors. These categories of supercapacitors are based on charging mechanism. You can see charging mechanism or charge storage mechanism. There are two types according to the charge storage mechanism. One is electrochemical or electrical double layer supercapacitors, and other is this model challenge 3 is not applicable. And the second is conducting polymers or conducting polymers used in pseudo capacitive electrodes. That is, pseudo capacitive electrode means it's a pseudo capacitor. Pseudo capacitor, name itself says it's not a perfect capacitor. Okay, now we will look at the definition of pseudo capacitor, which is non-Faraday. It's charged by non-Faradic uh, transfer of electrons or charges, and happens due to redox reactions, and these EDLCs are due to electrostatic effect, and these are made up of carbon type materials. You can see this. Okay, these are general definition. We'll look into this deeper in the next slide, where we have that segregated the definition, split into simple points that we can understand. So did we understand what the definition is? Obviously not. So now let's look in deep about the EDLCs and pseudocapacitors. What are EDLCs? EDLCs are the supercapacitors which are based on these points, which are electrostatic, means there is no electric charge transfer from one electrode to other electrode. Second, it's non-Faradaic because there is no chemical reaction taking place. Hence, there is no chemical reaction taking place, so it's not Faradaic. And it has two electrodes separated by electrolyte, and the ions in the electrolytes are attracted to the charges in the capacitor electrodes, so there will be formation of double layer. And yeah, we'll see that double layer soon. And these electrodes are made up of carbon materials such as activated carbon, graphite, etc. And yeah, we know that definition without imagination is of no use. So let's look into a small diagram. You can see here, this is uncharged, where you can see the ions are in different position. After charging, you can see there is a electrically double layer produced in an electrode. In a negative electrode, the positive ions will be attracted towards the negative electrode. So you can see two layers of charges. Hence, it is called electrically double layered supercapacitors. And the second point are pseudo capacitors. What are pseudo capacitors? These are the capacitors which closely resembles batteries, whereas EDLC resembles a regular electrolyte capacitor. This resembles battery. Hence, charging takes place due to chemical reaction. So it is Faradaic. And these are not really capacitors because of its similarity towards batteries, so it's called pseudo capacitors. And it has very high energy density than EDLCs, high capacitance than EDLC, and electrode used here are conducting polymers. So we lean more towards pseudo capacitors than EDLCs. Okay, and this is a diagram which you can use to understand how does pseudo capacitor works. You can see this positive ion is like absorbed by these charges here, and this happens due to the reaction which are taking place in the electrolyte, similar to a battery. Okay, now we'll see some supercapacitor electrode polymers, or polymers used in fabrication of supercapacitor electrodes. Yeah, as I told you earlier, these polymers have conjugation in them. You can see these are the conjugation here. Conjugation in them. You can see here. First is polyacetylene. You can see that conjugation, alternate double bond. Second is cis polyacetylene double bond. Here we have polyphenylene or phenylene, polyphenylene. We have this conjugation here, and all these conducting polymers generally have conjugation in them. Hence, it can conduct electricity. And we'll see the classification of these supercapacitors based on their electrodes or based on type of conducting polymers used. There are two types. You can see symmetric and asymmetric. In symmetric, both the electrodes are made up of same conducting polymers, but they can be doped like p doped and n doped. They can be both p doped or both n doped, or p doped, one electrode p doped and another is n doped, but of same conducting polymer. Where asymmetric has two totally different conducting polymers. And we'll see about the concept of doping here. Doping concepts include, this is very similar to the doping concepts in diode, okay, semiconductor diodes. So p-type doping is introducing a positive agent like Lewis acids to the conjugated structure, where it absorbs a electron from the structure, hence causing oxidation, which we know absorbing electron is oxidation. So it is also called as oxidative doping. And the second is n-type, which is doping negative agents like Lewis base to the conjugation, where impurities contribute an electron to the conjugation system, hence it is also called reductive doping. And you can see the reaction here. It's very simple reaction, you can understand. Again, there is a negative here. This is a positive agent, hence it absorbs an electron. You can see that an electron here, and it's called p doping. And here we add a negative agent, hence it becomes reductive, hence it is called n-type doping. Now we'll discuss about few polymers which are used in supercapacitors. I'm taking this polymer because these are like trending polymers or conducting polymers, obviously, which are used today because of its very it is very easy to produce, simple preparation techniques, and you can see its simplicity to synthesize, its low cost polymers and greater stability, and so on. And you can see the structure. This is an aniline, this is polyaniline, and it's produced by polymeric oxidation of aniline, you can see. And and we can like take general example of polymers. You can see the energy density of polyaniline is 140, which is less than that of very expensive metal oxide. As this point I left to mention, and without using conducting polymers, we can use metal oxide, which are very efficient in conducting polymers, but they are super expensive. Hence we use this conducting polymer. We add some doping, intrinsic and extrinsic types of impurities to make it better. We use carbon doping to enhance its property. Hence its energy density is little bit, it's more than that of regular simple chemical electrodes which we use, but not as much as the metal oxides. And yeah, we'll discuss about polypyrrole. These are very similar to that of polyaniline also. They are simple to produce, and they have similar qualities such as the polyaniline, and these are produced by oxidation of pyrrole units, where pyrrole units is oxidized in the presence of ferric chloride. And yeah, in comparison with polyaniline, these polypyrroles have high capacitance per unit volume because they are very dense. They're very dense than polyethylene. But because of this density, there are some few defects that the electrolyte ions cannot penetrate and associate with it like as easy as in the case of polyaniline. That's all. Other than that, these both electrodes are very good and they are less costly compared to metal oxides, since they are perfect for supercapacitor development. Hence, yeah, this video we saw types of polymers used, types of capacitors, and why we use polymer capacitors, and basically that's the main theme of the video. And yes, thank you for listening to me and watching this video. Thank you.